What do you get when you add 1, 1 over 4, 1 over 9, 1 over 25, and so on? You get the Basel problem. First proposed by Pietro Mengoli in 1650, it stumped mathematicians of the era for decades. It wasn't until a young man, age 28, came along from the city of Basel, where the problem gets its name, was it solved. His name was Leonhard Euler, perhaps one of the greatest minds to ever live. Born in a small house on the Rhine River, Euler was a prodigy. His father, a Protestant minister, originally wanted him to join the church. He nearly did. He enrolled at the University of Basel when he was just 13 years old. People tended to start their advanced studies a lot earlier back then. This is where he would meet Johann Bernoulli. A gifted mathematician in his own right, Bernoulli would give private lessons to Euler in the topics of math that he would teach himself throughout the week. Euler said this of the arrangement.
Rue, he was very busy and so refused flatly to give me private lessons. But he gave me much more valuable advice to start reading more difficult mathematical books on my own and to study them as diligently as I could. If I came across some obstacle or difficulty, I was given permission to visit him freely every Sunday afternoon, and he kindly explained to me everything I could not understand.
It was during these sessions that Bernoulli got a full understanding of Euler's gifts. He eventually convinced Euler's father to let him study math instead of theology at university. It's a good thing he did. A lot of the math that has built the modern world comes directly from Euler's work. When you write E, also known as Euler's constant, f of x, sigma to symbolize summation, you're using notation and concepts developed and popularized by Euler himself. At this point in history, the solution to the Basel problem was merely approximated to 1.6449340. Johann himself had proved the solution was less than 2, 1689 dissertation. This is what brought the problem to fame and gave it its name. Johann was at the University of Basel at the time of his dissertation. Eventually, after not getting a job at the University of Basel, Euler moved to St. Petersburg, Russia, where he took up a post at the St. Petersburg's Academy of Sciences. This is where he would solve this famous problem. Let us now take a look at his famous solution. Euler's first realization was that the Taylor series expansion of sine could be used in the solution of this problem. His next insight was to write this expansion of sine as linear factors, such as this. After taking limits and cleaning up the terms, we get this expanded version. Comparing this new series for sine of x and the original Taylor series, after picking out the x cubed term, we find, after a simple rearranging, we get this. This infinite series somehow includes pi, with the solution being pi squared over 6. And just like that, Euler found a solution for the Basel problem. And not just a solution, an exact solution, involving pi of all things. There were some parts that were a bit of a leap at the time and not considered rigorous enough. Namely, using the linear factors of sine. It took nearly 100 years until Weierstrass proved that. Euler's methods opened up new horizons in mathematics. Using similar techniques, he went on to solve the general cases for even powers as well. These results would later influence Riemann's groundbreaking work on the zeta function, a cornerstone of modern number theory. The Basel problem solution marked a turning point in how mathematicians thought about infinity. If you guys like this short video on Euler and the Basel problem, be sure to like and subscribe. I'm looking forward to making more of these short videos.